Welcome to the introduction to Tektronix New Gen family of instruments. I am Gail Morris, industrial designer, retired. It was July 1969, a few weeks before the annual Westcon Electronics trade show in San Francisco. Tech marketing was anxiously awaiting for several new products. New instruments from BHEN have been almost non-existent for months because so much of the engineering and technical resources, the tightly coupled manufacturing of components, proprietary parts and methods had been focused on developing new family of instruments. This new gen family now available with hands-on working instruments that marketing soon would be able to demonstrate to our customers. Tektronix brought most of the 300 U.S. field office sales and service people to Portland and booked almost the entire Benson Hotel for a whole week. The industrial designers were asked to prepare a visual explanation of the appearance and human factors attributes of this new gen family. The presentation was delivered in the grand ballroom of the Benson Hotel in Portland, Oregon. The media included 140 35mm color transparencies, 2 side-by-side Kodak ectographic projectors, and 2 10-foot by 10-foot glass beaded screens, one for each projector. We wanted maximum input from the pictures, so the ballroom was blackened out except for the exit signs. As a result, cue cards, notes, or other aids were not used. The narration and timing of the 2 projectors was done by me, the presenter. I practiced for many hours to coordinate the narration and the timing of the 2 projectors. At the end of the presentation, I announced all the instruments you have seen in this presentation are here in rooms on the floors above us. They are plugged in, powered up, attended by the engineers and technicians that drove them through development. All are ready for you to turn knobs, push buttons, and adjust anything you like to your satisfaction. That was 1969. Now for today. The original color slides have been scanned into a computer. The narrative was on cassette tape that I used for practice in 1969. That tape has been copied to an AIFF file that the computer can understand. This tape not only provides a voice explaining each of the pictures, it also sets the timing and duration of each picture while it is on the screen. The slides and audio tape have been archived, if you will, on a bookshelf in my home for over 40 years. What you are about to view is exactly what we had in 1969.
The application of industrial design to our new product can best be described in 2 parts. I will discuss the appearance design first. This company introduces many new products each year, but with the same old appearance that goes back some 15 years. Just a few years back, we were trying to accomplish a new cabinet appearance. But before this effort really got going, our product started taking on some physical changes. Solid-state miniature circuits were reducing the instrument sizes drastically. The electromechanical components, which provide the tactile interface with the user, were not keeping pace with the circuit miniaturization. The knobs and controls on the front panel were just becoming more dense, closer together, and difficult to operate. There were some far-sighted people in the organization that went to work on devices such as low-torque cam switches, circuit board push buttons, and scale factor readout. These components, when combined with the miniature circuits, allowed a further reduction in instrument size. But now, these tactile interface components were keeping pace with the reduction in circuit size. We were indeed off and running on the new generation program at this point. The first thing to do was establish the plug-in size. The choice of the 5 1/4 inch rack height was an obvious one, in that we just couldn't make it much smaller than that. The width was really established by our desire to get 4 plug-in units and space for the CRT in a rack width. Now this conveniently worked out to allow 6 plug-in units side by side in a full rack width, a format which is to be used for the new 2600 series of instruments that will replace the 160 series. With the plug-in size established, the industrial designers could set out on the task of designing the front panels in preliminary human engineering for every conceivable plug-in unit and mainframe that might possibly be built in the new generation line. Doing this exercise on paper enabled us to anticipate where the problem areas would be and coordinate the layout. It further identified new components that would be necessary to accomplish the instrumentation in the small size. It became apparent to us that the front panel of the instrument was going to have a dramatically different appearance than our existing product line. We then went back to the cabinet design problem and asked ourselves if we wanted a dramatically different appearance to the cabinet also. We thought not. The front panel would provide our new product appearance without a doubt. The design of the cabinet, then, must carry the Tektronix image into the new product line. We put together literally dozens of alternatives, and while doing this, we took a look at some of the characteristics of our old instrument design. The large knobs were well proportioned to the generous radius on the corner of the cabinet. Our new products are going to have very small knobs. Therefore, a scaling down of this proportion was necessary to a smaller radius on the corner of the cabinet. Out of these alternatives, we got down to one design that seemed to have a little more of the Tektronix look than the others. This design was then prototyped in these 3 instruments. The aspect ratios of a 4, 3, and 2-hole mainframe were quite different. We needed some models to work with. The models were constructed in a way to allow the trim features on the side of the instruments to be easily changed. The pieces were held onto the cabinet by small magnets, so various color combinations and finishes could be evaluated. We had well over 6,000 industrial designers on this project now. The organization participated freely in this activity. The exercise was well worthwhile, however. This combination of trim, for example, seemed to accentuate the length of the cabinet. We would like the opposite. This combination didn't look bad on the 4-hole mainframe, but resulted in a not so pleasing appearance of the narrow aspect ratio of the 2-hole mainframe. This combination made the cabinet look short and resulted in a much better appearance for the worst-case aspect ratio of the 2-hole box. It was also a very acceptable answer to the 4-hole mainframe. We also observed that our drawn anodized front panels provided very soft, warm highlights of the cabinet and produced an almost facial quality to the front of our instruments. This deep draw on the anodized front panel gave us the same facial quality to the front of the instrument, and it also provided a prominent area for the trademark, company name, and address. This is the final design. and I would like to call your attention to the fact that the power switch is the only off-the-shelf component on the outside of this instrument, and even that is manufactured in a special color for Tektronix. Every piece and part on the exterior of this instrument, even the BNC connectors, were designed by Tektronix people, and most of the parts are manufactured at Tektronix. Let's look at some package features. The carrying handle has been partially recessed into the top of the instrument. The grip is positioned over the center of gravity so the instrument will carry level. A great deal of time has been spent on the rear panel of the instrument. Our intent is that the design look intentional and not as an afterthought. Stowage for the power cord is provided, and it's done in a manner to allow the customer to unwind only the amount of cord he needs. You obviously don't need 8 feet of power cord to get plugged into a scopemobile. This corner detail of taper and radiusing to the front panel has set the precedent for other new products. Here it is scaled down in proportion to a bench cabinet for the 7M11 plug-in. The same appearance characteristics have been carried through to the Type 1101 power supply. The power cord storage feature is integral with a pedestal base for this instrument, and again, the customer can unwind only the amount of cord he needs. A new cabinet design for the pulse generators will be ready for the market early next year. There is also a totally new convertible benchtop rack mount package design for the R5030 instrument. The carrying handle has been placed on the side of the instrument to provide one-handed portability, suitcase style. This is a different concept than our present convertible rack mount package. That design was optimized for large, heavy instruments that require 2 people to carry. The handles on the front and back of the instrument provided a fairly convenient means to do this. But our new products are not going to be so large. They are in the 5 1/4 and 7-inch rack size and can be conveniently carried with one hand. The new design rack mounts in the same manner as the old. There is a new scopemobile for the 7000 series mainframe. It has storage for 5 plug-ins and a large drawer which will accommodate probe cases. From the side view, the scopemobile appears the same as that for the 530, 540, and 80 series. It is not. The new generation instruments have a CG and weight distribution that is considerably different. Therefore, the pivot point of the scopemobile tray has been moved forward 2 1/8 inches. The new scopemobile has an instrument hold-down device built into the tray. The mainframe has a detail in the corner bottom rail which fits over a locking bar. You simply flip the lever and the instrument is securely locked to the scopemobile. The graphic computer terminal represents a vast new market for Tektronix. Here, the industrial designer must deal with the appearance of an office furniture environment. Our goal is to enter this market with a very strong Tektronix product image, but with a conservative design approach compared to the competing products. I have a few examples. I think this one is from Flintstone Incorporated. You can't really draw a line between appearance design and the human factors. Therefore, I must take you back to the appearance model. It was apparent to us that we were in trouble. The front panels were dense and complex. There was an orderliness to the layout, but to the unfamiliar, it was difficult to find. We constructed some paper mock-ups that were quick and easy to change, and started the alternative game again. Many of the mock-ups didn't survive, and these tattered examples are evidence of the high emotion that ran through some of the meetings. But this exercise resulted in the color code scheme as used on the 5000 and 7000 series instruments. Our goal was to provide the user with visual cues and a simple logic that would mentally program him to the basic controls of the scope. I will go through each of them with examples of application to the instrument. Black and shades of gray are used freely on the front panel. It carries no functional meaning. All printing is black. Gray shades group or combine controls, such as the input switching and the connector, isolating the various output BNCs on the mainframe. Blue will program the user to determine the CRT display mode at the mainframe switching, at the vertical plug-in, and in the time base. In line of instruments, blue describes the YT of the 5030. The user around the front panel with green. Choose the trigger source. Another decision for the multiple choices arranged in time-based plugins in the same way. Trigger information, triggering of the 7T11 does not, therefore the color coding was handled in a different manner. The triggering section in this plugin is outlined with a thin green line. The same color program works with the R5030. Red is now used for nomenclature and controls that will uncalibrate the instrument. Yellow designates controls or modes of operation that require added care or attention on the part of the user. Orange programs the user for the current modes of operation on the 5030 line. Some examples of the alternatives to applying the color code to the front panel. These are all of the 7A12. The production version is on the right-hand side. The same kind of evolution for a time-based unit. Color coding is nothing new, but it has never been used to program the user in this manner, and it has never before had the commitment to such a wide range of products. We are much more dependent now on color for the operation of our instrument, and the color code will become a very significant part of the product image. Our intent is to tastefully apply the color code to the front panel. Use enough color to make it effective, but not so much to make it look like the Sunday Funnies. There is also a color code for the setup controls of the graphic computer terminal. It is not the same color code as is used for the measurement instruments. It was developed under a different set of rules for quite different needs. I will not go into it now, for a good detailed explanation will require more time than we have here. The logic of providing visual cues for the customer is carried on to the control knob. When a pair of coax knobs perform similar functions, the knobs are the same color. The nomenclature for the top knob is in lightweight lettering. The nomenclature for the base knob is in heavyweight lettering. As used in this example, both knobs determine comparison voltage. The top knob is a fine adjustment. The word fine is placed on top and printed in a smaller, lightweight lettering. When a pair of coax knobs perform dissimilar functions, the knobs are different shades of gray. The top knob, light gray, is defined on the panel with open or outline lettering. The base knob, dark gray, is identified by the solid, heavy lettering on the panel. In this example, stability and trigger level are dissimilar functions. The stability knob, on top, light gray, is defined by the outline lettering on the panel. Trigger level, dark gray, is defined with the solid black lettering on the panel. Another example is the VC reference identify push button, coax in the center of the position knob. Somebody made one of those foolish wisecracks one day that wouldn't it be nice if all the knobs that you weren't using would just kind of disappear. Well, we went off and made one, and it's used on almost all of the timing and vertical attenuator switches on the new line of instruments. When you press the center of this knob as if it were a push button, it unlatches and follows your finger out to reveal the variable control. This also switches in the pot and puts the instrument in the variable mode of operation. This uncalibrates the instrument, so according to the color code, the knob is red. When the variable mode of operation is no longer desired, you push the knob, it latches in, electrically switches out the pot, the red has disappeared, and the instrument is calibrated again. This magic hideaway knob is not always coax. At times it's used right down on the panel. And this mechanism is not exclusive to variable control. It will be used for other types of functions in the future. You can't have your own way all the time, and there is one exception. The 7A13 uses the conventional variable control, and the familiar coax push-pull knob performs the 10 times VC function. We had another problem on the front panel where the customer could get tripped up. The mainframe switching push buttons were oriented in a very logical way to the plug-in holes below. However, the push buttons for the horizontal modes also tied in the intensity controls on the mainframe above. The visual cue of the printed words on the front panel was just not enough. So we added the indicator lights adjacent to the A and B intensity knobs to cue the user which knob was effective to the display. And logically, when you punch up alternate or chop, Both the A and B intensity controls will affect the CRT display. So much for the visual cues and color coding. Our field engineers are going to get lots of questions from the customers about our push buttons, knobs, and the high density of controls. With a little background on this, we can make believers out of them. These are called percentiles. On the right is the 97 percentile man. This means 97% of the male population will fit within these dimensions. Now, most of this data is contributed by and useful to those designers engineering airplane cockpits and submarine hatches. Well, this doesn't do Tektronix much good. So we needed some percentiles of our own, so we searched out the 97 percentile finger. We determined the dimensions by touring the plant with an array of variously spaced push buttons. We chose the array that the fattest fingers could operate. The most important dimension in push button spacing is across the inside of the adjacent buttons. It is a function of the thickness of your finger plus the inward travel required to latch the button in. We have a different spacing for the horizontal matrix of push buttons. The finger is wider in this axis. The mainframe switching buttons are a different design concept altogether, but the spacing is the same. This is the 184 time mark generator. It uses an off-the-shelf switch from Oak Manufacturing Company. It is widely used on electronic equipment and accepted as an industry standard. It requires greater inward travel to latch the button than do our new switches. My point is this: we have improved upon an industry standard, and in a way that allows more usable front panel space, and because of the small aperture required through the front panel, solve the EMI problem to boot. The customer has been giving our field engineers lots of comments, or shall I say abuse, on the knuckle scraping knob arrangements on our front panels. These new products have made some gains on this problem also. Let's look at a delaying time base. The basic setup controls, or seldom used controls, are in the form of push buttons and down close to the front panel surface. The only controls that protrude from the front panel are the frequently used controls. When you consider only the knobs on the front panel, there are only 4, with a reasonable amount of space between each of them. The cam switches require little torque and can be easily operated with 2 fingertips. The dual trace vertical amplifier is another example. There are only 2 controls that protrude from the front panel. The 7A13 is a complex instrument indeed, but again, there are only 4 clusters of knobs protruding from the front panel. If you have the theme of this thing by now, look at this complete dual beam oscilloscope with more features and flexibility than instruments twice its size. When I think of appearance in human factors designed together, an example of cluttered appearance and impaired front panel controls, I think Tektronix has made a contribution to the industry. Thank you very much. Dual beam oscilloscope with more features and flexibility than instruments twice its size. When I think of appearance in human factors designed together, an example of cluttered appearance and impaired front panel controls, I think Tektronix has made a contribution to the industry.